Dear participants, let us welcome for the session Professor Ram Kumar from IIT Kanpur. He is a senior professor from IIT Kanpur and has vast experience of working in the field of micro nano manufacturing, product process development, tribology, composite manufacturing processes, modeling. And we are really lucky that we have such a highly what happened so, such a highly learned professor with us, and will be benefited by the lecture given by sir. So I request sir to kindly start his session.
Okay. First
Yes,
of
sir,
all,
you
my
are welcome.
apologies. There was some technical issues, and second apology. Sorry for shifting from tomorrow to today. I had some other official commitment from the institute. I had to go and other things. Sorry, and thanks to all the organizers for accommodating me in bringing this lecture. So I would like to thank all of them, the head of the department, the coordinator, and the technical in charge, everybody to help me in connecting with you guys. I always love to come to Agartala, but this time I could not make it up of the end semester pressure. But I would always look forward to come to Agartala. Agartala is a very loving place. And there were some students from Agartala who came here to do some experiments for their thesis work. So I have a good association with them also. So saying this, let's get into the topic today. Manufacturing is something very interesting. In manufacturing, if you look at it, there are only three important parameters in manufacturing. One is pressure, time. The third one is temperature. These are the three important parameters in manufacturing. You can have all the three, you can have any two, or you can have one. For example, you do heat treatment, it is time and temperature. You do metal forming experiments, it is pressure and time. Okay. So the difference between metal cutting and metal forming is basically the loads what you apply and the time. In metal cutting, the speeds will be phenomenally high. In metal forming, the speeds will be very low. In metal cutting, the pressures point per unit area is very large as compared to that of metal forming. So if you go round and round and round, if you understand exactly the material property, and then if you know also the process and its parameter, its influence, then you can start dictating the output. For example, the first part itself, what you get can be the best part which can be put into reality. Today, we are more focused towards online monitoring. Why are we?
Sir,
Yes,
yeah, sorry for interrupting. Sir, actually, your slides are not moving, sir.
sir.
Slides are not moving, sir.
No, I am not moved to the second slide. I'm just giving an introduction.
Okay, sir.
Okay. So when you talk about today's manufacturing scenario, in manufacturing scenario also what we are looking ahead or looking forward is making the right part, the first part, the right part, and the best part. So here when we also have to do that, so we are looking for online monitoring such that the quality of the output can be monitored and you get the good part out of it. So here there is a need for understanding the process and for also trying to make the best out of it. So manufacturing has been around for last 50 years. So there are so much of data available. Now, what do you do with all those data? But every time when I start doing another part new, I have to do once again trials. So because of that, now what is happening? There is a huge need both from manufacturing community and academic community that we integrate deep learning, machine learning algorithms for producing the required output. Why is it happening now? Why did it not happen in the past? Because now we have very high computation facilities. We have good algorithms which can work on the data, right? Which can work on the data. So that is why today there is a big initiative given for machine learning, IoT, and Industry 4.0 all together in manufacturing. Where is this going to go? This is going to take us to a new era. So in this new era, we need experts, engineers, we need master students, we need PhD scholars to understand the process and use the data judiciously. That is why all across the globe we are talking about Industry 4.0. In Industry 4.0, if everything else you have, it's not only the connection, it is also the interpretation of the data. So here, machine learning also becomes a very, very important tool. That is why, thinking about all these things, the organizers have kept 1 or 2 lectures in the area of machine learning. So Python is being taught to you in the as part of the course, and other many more things are taught part of it. So all these things are more developing is Python. Understanding is machine learning understanding. So this is what I have made it. Machine learning, the paradigm shift. This is going to shift manufacturing from a very low profile to a very high profile. So when we talk about machine learning, exactly means it's more and more and more algorithms. What are algorithms? Algorithms are nothing but a simple way of solving a problem. For example, when we do the calculations, multiplication in your school days, we have been taught a way called as Bodomas. So how to remove the bracket, which comes first, which comes next. That is an algorithm. If you use that algorithm, what is the advantage? You are going to go towards the closure very fast. By the way, why is this board mass taught? Because in reality, there can be situations where in which you multiply certain things, you try to square multiply certain things, add certain things. So what was taught in words were converted and presented to you in mathematics form. So you used a board mass algorithm to get the solution. This was taught to you in class 4, 5, and 6 mathematics. So algorithms are being part and parcel of life. Algorithms are set so that what you do is you try to play with the formulation of the problem and try to go towards solution. Learning, there are 2 types of learning. One is called as structured learning. The other one is called as unstructured learning. Structured learning is you are going to a class, you start trying to solve a problem and understand more and more and more. Say, for example, you have been taught physics in class 10, then you have been moved to class 11, then you have been moved to class 12. So every time it's a delta x addition. So this delta x addition will keep on be adding. And then finally what you get is the output, whatever it is, right? That is called as structured learning. Unstructured learning is I don't give you a problem statement. I just tell you a situation. For example, currently we are working on how to generate a dry mill which can machine wheat for 50 kilos of wheat. So every day we wanted to do only 50 kilos of wheat has to be powdered, and this has to be done. It has to be done in 4 hours of time. It has to add to the livelihood of people for women who can work 4 hours a day. So here what we did is we did not talk about what is the grinding wheel, what is grinding mechanism. It was completely unstructured. You learn by doing it. So that is learning. And today, whatever we learn, we try to improvise. So improvisation is also part of machine learning, right? Improvisation, analysis of data. Analysis of data is very important. See, for example, if somebody tells you that I give you 3 data points saying that the mean value is -3, 0, 3. If you try to find out what is the mean of these 3 data points, is absolutely 0. But if you use that 0, so then what happens? You have taken 3 data, but now you say an output is 0. The other way around is for the same data, -3, 0, 3. If you do an RMS value, then you try to see more information, and that is what is analysis of data. So analysis is also part of machine learning. The next thing is autonomous. Today, we are not trying to look at every time getting connected to the base, but rather than you have your own intelligence and then you start doing it, just like human being. So we talk about human being, you please have your own intelligence and then execute, rather than approaching somebody in the main server, trying to make it as autonomous as possible. So that means to say have as many algorithms and informations integrated together. Neural network is a powerful tool wherein which you have we have been using forward propagation and backward propagation. Forward propagation means you will have input layers, then you will have inference, whatever it is, and then you will try to have a connection. So between the inputs and the processing, whatever it is, you will try to give weightages. These weights will be reiterated such that you go closer to the answer. You can have backward propagation, feed forward propagation. These things are part of neural network, which has been there around for the last 50 years. Before even getting into neural networks, the important thing what people do is classification of data. For example, there are some 20, 30 participants in this QIP workshop. So now if I want to talk about all of you, the first simple thing what I will do is I will try to divide you as male, female. Then I will try to divide you as less than 30, above 30, or less than 30, 30 to 50, 50 above. So I can say, and then I will say that middle level people, more of women are attending this course. So that is a classification done based upon the data. Talking more, I don't talk about Nalini, Usha, Rani. I don't talk about them. I say there are more ladies. They are all middle-aged and they are attending the course. So with this interpretation, I will say women of middle age have started taking life serious and they are doing courses. So how did I do it? This is based on classification. So classification is also very important. So initially, if you see in manufacturing scenario, we have a go gauge, no go gauge. It's basically classification. But with this no gauge and no go gauge, you cannot interpret and talk about the process. You will only try to say yes, no. So classification was the initial filter for understanding the data. And then data mining and the algorithm, the data mining is understanding more of the data. Artificial intelligence is part of it. So if you see all of them, they are part of it. Deep learning, artificial intelligence, data mining techniques, classification, neural network, autonomous, analysis, improvise, learn, algorithms. They are all put together in one terminology called as machine learning. For this machine to understand and learn whatever it is, you have to keep giving them algorithms. And your algorithms should be validated with realistic data such that the understanding is more and more truthful. Machine learning is also followed in a lot in your Google. For example, Google, first 5 times you keep on searching about Shah Rukh Khan and his movie, or try to put Dhoni and his stance, or Dhoni winning matches. So what happens is it will try to pick from across the basket whatever is available, and it will try to show. And next time, whenever you search, it will try to give all the time the videos which are Dhoni and his cricket match, or India and his winning against Pakistan, or India gold medal in wrestling. So something like that. It will keep showing all these things, which are all again, machine has learned what is your requirement and it starts giving it. Machine learning is also used for possible English corrections in our grammatical correction is also part of machine learning, right? So understand what is it written and then try to see the sense of the statement and then do. Now chat GPT, which is talked about, where in which they talk about AI, machine learning is exhaustively used. But after the data is given after chat GPT also, don't think everything is correct. And let me give you a simple example. There is a frog which had 4 legs, right? These 4 legs, what they did was, there was a researcher and then he was trying to do a dissection of the frog and then try to talk about the frog. So one of the researchers said he tried to nail the frog, right? And then he said, okay, let me cut each leg and see what is its interpretation. The first leg he cut and then he said jump. This was trying, because of pain, it was trying to move up and down. Then the next leg he cut and then he said again jump. It was struggling, it was trying to flip. The third leg he cut, it was again having little bit of life, he was trying to flip. The fourth leg he cut, it is almost dead. So the researcher interpreted saying that once you cut all the 4 legs, the frog becomes deaf and dumb. But the true thing is the frog is dead. So understanding the data is also very important. If you allow the interpretation to keep on give you suggestions, it will mislead. Okay, so this is with of caution. So now let us see what is the difference between machine learning versus deep learning versus AI. So when we talk about AI is the outermost, is a big set. Then inside this big set you have machine learning. Inside the machine learning, what you have is deep learning. So these 3 things are one after the other after the other. Okay. These are one after the other, and it can be used for interpreting the data. So now if somebody asks you a basic question, where is AI versus ML versus this, you can quickly say this is what is the spread and how is it done. Okay, so I told you already structured learning and unstructured learning. So in structured learning, machine learning, you will have unstructured learning and structured learning. Unstructured learning means you have groups and intercept data based on the input data. So you can have age, you can have this, you can have that. All these data you can give, and then you can start doing unsupervised data. Basically, first what you do is you try to do some clustering, right? Then what you do is you try to look at what is happening in that data and then come out. For example, if you are trying to collect all the machining process and trying to put all the interpretation of the data, all these things, it is called as clustering of data, right? The next thing is supervised learning of data. So here you will try to do a regression model, or you will try to do classification algorithms, then develop prediction on the model based on both input and the output data. You get what is called as supervised learning, and it is unsupervised learning. So what is supervised learning versus unsupervised learning? You see that input data is apples. Then you have these are, so then you have an annotation, these are all apples. Then input data is all these things. Then what you do is you try to have a model which can classify all the apple and then all the bananas, right? So suppose let us do something like this. You try to close your eyes and I show a banana in front of you. Can you try to touch the banana, feel the banana, and say whether it is damaged, or whether it is fresh banana, or whether it is something else, right? So if you want to do that interpretation, you should have data. Just by length to aspect ratio, length and diameter, you can't keep on be classifying it as good banana and bad banana. You can only put all bananas together, right? So unsupervised learning is so this is the unsupervised learning means you give this and then ask what is it. So right, so then he will try to interrogate, is it an apple or is it an orange? So that is unsupervised. So supervised is you try to give everything and then you try to get it. So data is supervised versus unsupervised learning. So unsupervised learning can lead to labeling of data. Unsupervised learning means it is unlabeling of data. Hybrid model that includes supervised learning is going to be labeled data as well as unlabeled data. Labeled data means age 23. So you don't say age, you say only 23. So that is unlabeled data, which is unsupervised learning, right? So all these things are talked about. So today we are trying to move towards unsupervised learning and trying to interpret the data. So what are the different classification techniques which are there? So when we try to do the classification technique, so you say that you see a lot of incoming messages are coming. So you try to put a filter, right? All your Gmail, everything puts a filter, and then it tries to say spam, and then it will try to say inbox. So it does the classification. How does it does a classification? In the past, you would have deleted, or several of the people would have said that this is spam. So it goes into that, right? So that is classification model. Input data, it tries to figure out where does it have to fit in, and then it puts it there. So in between the model, whatever you have, there has to be a training and validating of data has to be there. So that is done. So 10 times you will always try to push the data to spam, or you declare that as spam. It tries to check the keywords there, and then it will try to put it into spam. So the classification techniques are predicts discrete responses, whether an email is genuine or not. The other thing is we will try to do whether a tumor is cancerous or not. That it is very important. For example, if there is a small tumor, or if there is a small you do an NDT analysis, non-destructive analysis, and then you try to figure out there is a small small hole or in something in the plane. So immediately you try to see whether it is a defect or not a defect, or whether it is a signal problem, or is there is a curvature. See, all the techniques in manufacturing holds good and works good if the geometry is simple. Moment you want to do roughness on a roughness on a depth curve where the aspect ratio of the hole is maybe 100, diameter is too small, it is 100. So then you get into trouble. So we always look for other techniques, right? So the application exhaustively used for classification is medical imaging, speech recognition, and credit scoring. So all these things are applications which are based on predictive learning and other things. So regression techniques, we do multi-regression techniques. We have a single variable, we have multiple variable. You try to do regression analysis, very simple. Linear regression analysis, y equal to mx plus c. And if you want to increase the linearity to exponential, and then keeps changing the model, whatever you predict. And then you always try to look out for R square data. R square data tells the validity, how close or how far away you are there from the original data. So you can try to talk about it. Okay, so regression models, we always try to do in all the manufacturing thing, we always convert everything into linear and do a linear regression analysis and then try to figure out. Many a times, linear regression analysis is a very good approximation. So we are still happy. Computation time is low. The whatever results come is interpretable, and then we do. But today, people have realized that that is not going to help us more. So people have moved to non-linear models. In non-linear models, you also try to do the analysis. For example, regression techniques today are hard to measure physical quantities such as battery state of the charge, electricity load on a grid, or prices of financial assessment. All these things are nowadays continuous data which is done. So in India today, what is happening is the price tagging is fixed for a day. Slowly, days to come, they will try to convert it into hourly wise charging pattern. So the costing will be so dynamic. So here, what do? Is they do forecasting techniques and they do linear regression analysis and they try to interpret the data. So the regression techniques can be used for visual sensing, can be used for electricity load, it can be used for algorithm of trading. You can use. So this is the source, this is the output. So you have sunny, you have overcast, you have rainy. So it's based on wind, yes, no. If it is overcast, it is this. Temperature, if it is this. Now with this, you try to develop an expert system or an algorithm to find out what is it. Unsupervised learning is like structured, all the data are there. With all the data, what you do is you try to make a model, and then after making this model, you try to cluster it. Finds hidden patterns or in the intrinsic structures in the data. So that is what is unsupervised learning does it, and then used to draw inferences from the data set consisting of input data without labeling responses. So that is what is unsupervised learning. So clustering, I've already told you, resources, identify and eliminate outliers. Then it tries to generate minimum spanning tree. Then it is merge learning resources into cluster, merge small clusters by this thing. So these are some of the things which are merger small clusters by distancing. So you try to do this clustering to get the so raw data is this, your algorithm is this. We try to classify data, put it into a different box, and whatever you put, you should understand the aspect ratio of pear and aspect ratio of apple has to be done. And even before doing it, the color has to be done. So based on color, they do a classification, and then based on other things, weight and other things, they do a classification. This is how we try to do clustering of data. Clustering of data is very important when you look at machine learning. So here we try to talk about classification. Classification is nothing but clustering of data. So this is how we classify versus clustering. Classification is you say all less than this weight and height are children and more than this are adult. So there can be a child which jumps from here and falls in the adult, or there can be adult with the height and weight which falls less than this. Okay, so you can try to fall here and there. So classification is one hard line you draw and then you do it. What is clustering? Clustering is you try to cluster them based on some similarity. You don't do it only with height and weight, but you also do it with other algorithms so that you try to cluster them. Maybe the date of birth. So here you don't put date of birth. Here you put the date of birth. So then you try to form, and all the clusters need not be circular. It can be long, it can be oblique, whatever it is. So cluster 1 versus child characteristic, cluster 2 versus child characteristics you can have, or adult characteristics, and then you try to form some similarity. So I hope you are able to distinguish between classification and clustering. Classification is if the cutting force is more than this value, stop machining. Even though it produces good parts, we just say since the cutting force has to cross this, we stop machining. So that is classification. And what is clustering? It tries to have multiple data and then multiple similarities, and then it forms a group. That is clustering. Clustering of data is also a big challenge. Then comes a bigger thing. How do you decide which machine learning algorithm to use? There are a number of machine learning algorithms. So you are supposed to, this will be a flashing question for you. How do we decide which machine learning algorithm to use? Choose supervised learning. If you need to train a model to make it predictive, so you please choose that. Choosing unsupervised learning is a different story, but choosing supervised learning is always better, and you try to use it. So choose supervised learning if you need to train a model to make it predictive. So today, what are we trying to do? A lot of papers which we start publishing are always trying to do experiments, understand the data. From the data, you do optimization. That is nothing but supervised. You do optimization, and finally you say, you do this parameter that will try to give you a best result. That is what you do. But in reality, if you have everything there, then it is okay. If you don't have, then the best thing is you try to take the data. That is nothing but unsupervised. Okay, so that is what it is, right? Choose supervised learning if you need to train a model or to make a prediction of the example. So that's what we do. A future value of the continuous variable, such as temperature or a stock of price or classification, all these things are part of supervised learning. When you choose unsupervised learning, you need to explore your data first. Wanted to train them and then give them the data which is used. So such as splitting of the data, clustering of the data, you try to do it and then convert it from unsupervised learning to supervised learning. So key points for choosing machine learning algorithms. Some questions you can ask that can help narrowing down your choice will be, what should be the size of the data which you will be working. See, today we do only 25 experiments, and then we use machine learning algorithms. And then we'll do machine learning algorithms, and then we try to talk about the system. Okay, so that is what we do today. But how many data points to do? So that is what is the biggest question. So some questions you can ask that can help you narrow down your choices are going to be, one is, what is the set of data size I should work? That is very important. Just doing 18 experiments and talking about how I talk everything under this is not allowed. It's not accepted. Next is what's the type of data you will work with? That is also very important. Are you going to work with text? Are you going to work with words? And today, if you look at it, a lot of interesting machine learning tools have come for text. For example, the news, whatever you see in the internet, the first thing what you have to ask is a question is this news authenticated or is it real? So how do you find it out? If it is real, unreal. So today there are machine learning techniques in which they use the text and then they try to find out what is it. From there, they try to see whatever information this particular website is giving, whether it is truthful or not. Okay, so this is what is the interpretation, right? So, what's the type of data you will work with? Then, what kind of insights are you going to look forward from the data? You have a huge set of data. This huge set of data, what are you going to interpret out of this data? That is also very important. Just like, okay, you go to a doctor, he asks you to do multiple tests, right? And then he should know very clearly what is the output he is expecting. If he is expecting there has to be something shown in the pathology report. Then he starts working on it. So what kind of insight are you looking for from the data available? Then what will be the insights useful for? So these are the 4 questions you should always ask. Many a times what happens, we do a lot of manufacturing experiments. We measure the temperature, we measure the vibration, and then we measure other things, right? Temperature, noise, all these things we measure. And then finally you should ask a question, what are we going to derive out of all these data? You have got an audio data. How good or bad is this data? Right? And then if you have a raw data, then if you can process it and try to figure out what is it. Suppose you have a sensor. The sensor is not able to record the time frequency as per the event what is happening. For example, you can use a strain gauge and measure the forces, no problem. You will use a force dynamometer and measure it. When you use a strain gauge, it always gives the max value. And another thing is, if the strain gauge has reached its maximum value, after that, whatever you do, it will only say 5 centimeter is the expansion. That's all. So now you get those data. What do you do? So now what I'm trying to say is, you try to figure out if there is a deflection, put some other methods, find out whether the deflection is only this much. On top of it, then you want to some more data, you can do. So these are some of the questions you should ask. What is the size of the data you would like to work with? What is the type of data would you like to work with? What kind of insights are you going to look forward from this data? And what are those insights going to be useful for you? People keep on trying to talk about, okay, some politician making money, some people making money. How is that going to impact you? That data is available in the market. How is that data going to influence you? Are you going to be rich or poor based on that data? So that is what is the insight of the data. Why machine learning matters more? More data, more questions, better answers. It is exhaustively used in automobile industry today. Then it is also used in aerospace and defense. For example, Indigo flight runs all across the country, right? So do you think that Indigo flight owner has bought all these flights and he's keeping it for himself? He would have taken it from lease, from this some Airbus or whatever it is. He would have taken it. And then what now Airbus does is, they say they give it on lease, rent. So for every hour they fly, they should give so much of money. And for every hour they run, they have the companies like Airbus, Boeing, they record all sorts of data. And all this data is used for interpretation. Okay, so this is what it is. So next is manufacturing analyst. So manufacturing analysts are exhaustively used for other interpretations. So manufacturing analyst is one, and then medical field. Today there are more and more data coming out, sir. See, one thing is only, if you are looking for very trivial things like what is the cyst for cancer and all, is a different story. Now, if there is a cyst in the brain, how do you approach it? And what are all the different techniques available? And for this, whether whatever is there inside, whatever doctor is interpreting, whether it is of sense or not. So all these things are come in this medical devices and signal processing. So here, when you use all these things, machine learning is going to help you in doing it, provided you know what to ask from the algorithm. So what are all the prerequisites of machine learning? The basic knowledge of programming language like Python, R, Java, JavaScript, all are very important. So you should develop a program, right? The algorithm, whatever you think of, it has to be developed. You should have a very good knowledge about statistics and probability. You cannot keep on be doing mean. You can't keep on be doing mean. When you start doing mean, nothing comes out. You have to understand whether to take a ratio, whether to do for RMS, whether to go for kurtosis, whether to do for skewness. All these things you should understand. And it is R square plot you have to take, this square plot you have to take. All these things you have to understand. And also the probability of an event to start, event to end, event to happen. Next one is basic knowledge of linear algebra. Why is it always talked about linear algebra model? In linear regression model, a line is drawn through all data points and the line is used to compute a new value. Right? We always use linear, but not necessarily all the data fall in the linear algorithm. So suppose you have a set of data, you can ask that question. You have a data, there are a huge set of data plotted in the XY. Now you try to draw a line and try to find out which is the best line fit for the equation. So it is done. So understanding calculus is also very important. Knowledge to know how to clean and structure the raw data is also very important. See, today what is happening, you get more and more and more data in your Google. So now all these Google data, there are a lot of things taught online. There are a lot of things that are taught using models and other things. So during the time of learning, yes, it is very structured. You will learn a lot. But after some time, you will have a lot of questions and cluttering happening. So now it is always good to have a knowledge on cleaning up what is cluttered knowledge and structuring the raw data such that it can take you to the output in the required fashion in a shortest time, and the decisions can be made. So this is thought of very important. For example, many a times this is what happens if you see machine learning is exhaustively used. They say that, okay, here is a culprit who is seen here. Next, they say here is a culprit who is seen there. This used to happen when I was young. When Rajiv Gandhi's assassination happened, they were trying to figure out where the culprit is. So they used to say Sivadanu was was there, and then he had a very skewed cult figure. So if you try to open a newspaper, in the first page, they will say Sivadanu was located at this X location. Then in the second page, they will say located at Y location, Z location, alpha location, beta location. So you will have all sorts of information there. So these are all data. Now you have to clean up the data. So assuming that whatever interpretation they give, how close is their interpretation, whether he is located at X and Y, which are very far off. So all these data they will try to see. And what they do is they structure and then they do. By doing so, the CBI or the Intelligence Bureau of India, at those times when there was not much of machine learning techniques and computers, they easily figured out where the culprit is and they shot him. So that was all a human having a lot of intelligence and learning. Now, if you want to ask a computer to do it, is doing it. Today, Google works like that. Snap GPT, Chat GPT works like that. You take any software, it also works like that only. So moving forward, so what is the difference between machine learning and deep learning? Artificial intelligence is a set. Inside that is machine learning is a subset. Then deep learning is a subset. So the artificial intelligence is science devoted to make machines think like a human being is artificial intelligence. Machine learning is focus on enabling computers to perform tasks without explicit programming. So that is machine learning. So now what they want is they wanted to add this machine learning into every small device. So this small device will try to say it's a data wrong, data right, good data, alarming data, everything it will try to give. Next is deep learning is a subset of machine learning based on artificial neural networks. So if somebody says deep learning, it is a subset of machine learning. Machine learning is a subset of this. Deep learning is a specialized form of machine learning. So the difference between machine learning and deep learning. So quick to train model is in machine learning. A lot of approximations, but it can train. Accuracy is plateau. To some extent, you can try to talk about the result. Good results with a small set of data is machine learning. A train on a CPU is also good. That means to say a small server or memory space is required. Then try to fit a lot of things for the best result is machine learning. What is deep learning? Intensive computation is deep learning, and unlimited accuracy. So you try to talk about fourth order, fifth order, sixth order. Requires millions of data points, and then train better on a GPU, CPU, GPU, and then learns features automatically is done by deep learning. For example, the performance with the amount of data, as the amount of data is increasing, the performance of deep learning is increasing. The older algorithms were always saturated, but deep learning, the machine learning algorithms reaches a plateau. This is what I said, plateau. That is accuracy plateaus. So, but here you see the performance keeps on increasing. How data learning technique scales with lot amount of data. So using all these things today, we are trying to learn all these things like machine learning applications, speech, automatic learning, medical, stock, online fraud. Online fraud is pretty interesting. We are recently working on it. For example, if somebody tries to hack money and then take it from your bank account, we are trying to figure out how does he do, why does he do, where does he do, all these things we are trying to do. Then virtual personal assistants, then spam, which you are always enjoying, self-driving car, product reconsideration, recommendation, or traffic prediction. At every place today, we use machine learning in a big way. So the machine learning in manufacturing happens in predictive maintenance. It happens in logical, analytical, and supply chain management. Advanced digital twinning techniques are used, and then you will also have energy. You will also have energy, which is the energy utilization and prediction, where now people are trying to say what are the machines to be used for the interpretation. So they are working on it. So the next one is the next one is very important. The prediction of quality and the yield is also done. When we talk about predictive maintenance, the gadget it can try to find out the fault, whatever is happening in the machine and outside the machine. So that is one thing which is done. So the next thing is supply. You see now, government of India is trying to use this logistics and supply chain management. It is called as Gaja Shakti or Ganu Shakti or something like that. So it's a big supply chain logistic in this thing management. They have given pumped in money in order to figure out how do we operate logistics, how do we always maintain a critical stock in getting it. Here also, machine learning and deep learning plays an important role. The suppliers must provide sufficient and high quality material, and then AI helps in handling the inventory and other things. Almost all the warehouses, let it be Amazon, let it be Flipkart, let it be Snapdeal, everybody uses machine learning to understand the data. Based on the past data, they try to predict and keep the customers for the next thing. So then this is the advanced in digital and twinning utilization can be done. So this is other thing which is used. So twinning is like, so you have a data. So from the data, so data twinning is exhaustively used for initially by 5G people, they were used, and today it has moved down to manufacturing because of its learning, right? So the advanced twinning techniques are used. Energy utilization I have already talked about, and prediction is also talked about. So the benefit of machine learning in manufacturing environment I have already talked. Better supply chain management, improving quality, and then lower product cost. So all these things are part of it. Improving product quality. Okay, machine learning in a CNC machine. So what happens is, suppose you have a cutting tool, you are trying to measure the cutting interpretation. So you will have a strain gauge, then you will have a force dynamometer. So force dynamometer measures this thing, and from the measuring parameters are Vx, Dx, DC, and F. So this is all fed inside ANSI, ANFIS. Then what you do is you have the feature recognition, and then you have utilized the feature extraction we did, and from there we try to get the interpretation, whatever it is. So this is what, and then we try to have a data acquisition code. Then we try to go for machine learning. So this is completely a system which is learned on machine learning and CNC machines, which are exhaustively used. And today we are trying to do for even the first part, it is getting it done. So machine tool monitoring, it does sensor selection. You have to understand the different types of sensors which are available today in the market are current sensor, force sensor, laser sensor, accelerometer, acoustic sensor, sound sensor. All these things are there. You have to choose one. You cannot choose everything. That's what I said. You have to choose what do you want from the output you are supposed to do, and so that you accordingly choose. Then what you do is you do signal processing. In signal processing, you try to do the segmentation, time domain, frequency domain, time domain data, frequency domain data. So then you analyze the data, and then you try to figure out wavelet analysis is done. Denoising, signal to noise ratio is understood, and then we try to do the interpretation. So that is one. And then the next thing is feature recognition. We have already discussed about feature recognition. And then you also have intelligent models. Intelligent model is deep learning versus machine learning versus deep learning. Regression, classification, all these things are part of it. So then you will have decision making, tool condition monitoring, chatter deduction, and you also have surface roughness modeling and dimensional accuracy. So all the dimensional accuracy, all these things are now done part of decision making in deep learning and machine learning. So these are all data-driven intelligent monitoring techniques. So if you want to do machine learning monitoring, you should have a proper choice of sensor, signal processing technique, then feature extraction technique, and then you will try to, so here feature extraction, you will try to do classifications and other things, and then you will try to do the interpretation. So this is other thing. This is other thing which is done, and then you try to do it. So next one is like feature recognition. You can see that machining process. This machining process, you will have machining features like hole, slot, pocket, island. So now all these things are given. You put it in a table, and then you try to, moment you give the feature, from the feature it is able to find out. It is able to find out which one, which process to use, and which process can be done sequentially. And looking into the tolerance, it can be also done. So these are some of the techniques which are used. Okay, so now when you move forward a case study, machining features, feature recognition are like this. So you will have, these are the features. From the features, it tries to say face. From the face, it tries to see the link between the face. What are the faces? And then it tries to see the part. Then it also goes to the CAP, computer process planning. It tries to plan everything and give you. Machining information experience construction is also done. And then finally, the CNC is used to make the required output. The CNC manufactured products using machine learning. These are some of the products which are exhaustively used in companies. And these are products which are done by machine learning techniques. And it has been now commercialized, and it has been exhaustively used. ML in additive manufacturing also is thought of today. So you will have raw material, you will have a preset of the machines, whatever it is done. And then what you do is you try to take sensors, you try to measure the sensors, you try to take the sensors, and then you do pre-processing, and then you do machine learning, and then final processing, you get the required thing. For example, what to set, what angle to set, what are the, how many layers to cut, all these things it is doing, and then machining time optimization, everything it does. So material design, topology design is designed for additive manufacturing. Additive manufacturing production is manufacturing planning and AM process, so powder spread and other things. So every parameter is taken, and they do a lot of optimization to get it. So you can see that optical microscope, the microscope of the first track can be done. So these are some of the cases where AL is exhaustively used. Melt flow is done. Then as built part is seen, 5, and then you see that spatial observation, and then 6 is porosity doing. So the general concept of hybrid additive manufacturing is CNC machine, additive manufacturing, put together additive manufacturing. Today we are trying to talk about high-speed additive manufacturing, HSAM. So we talk about without machine and then all these things. So you see what are all the different process parameters: scanning speed, laser energy, flow rate, pitch path, printing path, and layer. And in situ anomalies can be over extrusion, under extrusion, warping, delamination, surface roughness, porosity, and digital information can be supporting all those things. All these things are fed into algorithm driven. So you have topology optimization, design of experiments. All these things are done to get the required output. So then you can see a model with powder dynamics, CFD, FEM, SCA, And then you will also have heat source, grains. All these data is used to get the required output. So in a closed loop monitoring system, you will have laser, you have in situ, you have, these are the outputs. You can try to reduce the cost, you can try to improve the quality. So NASA Perseverance rover is also made using machine learning techniques. They printed all the parts by this, and then they finally try to assemble and then try to get the required output. Why is AM attracting interest lately? Availability of CAD/CAM or softwares are made. Automation is widely used. A huge data of printing is there, and then ease of rapid prototyping is happened. What are the potential benefits today from mass production? We have gone into mass customization. So direct translation of the design part is done, zero waste. So because of all these things, sustainable reduction, all these things they try to do it as done. So the current trend is global trend in additive manufacturing. You have additive hierarchical manufacturing, process analytics, and machine learning is added to it. So data-driven manufacturing is the talk of the town. Energy storage, smart sensing, research facility, high-quality performance training, industrial collaboration. All these things are happening today to have a current trend of global trend in advanced manufacturing, which is happening because of this. Which technologies do you think will be the biggest impact on product design and development over the next 5 years? Additive manufacturing will have 52%. All other companies will have from 5%, 8% to 52%. So today, digital additive manufacturing is Industry 4.0, IoT, segmentation, DFMA, classification, all these things put together is deep learning plus additive manufacturing, which is automation in additive manufacturing. So the path of digitalization is going to be identification, assess, communication, security, design, distribution, print, delivery, and quantify. So the pillar industry 4.0, it is what it is. We have discussed in plenty. So machine learning is part of industry 4.0 to come up. So from industry 4.0, we are moving into smart factories where there is no man, everything and by the machine, by the parts, by supply chain, everything will be done. That's called as smart factories. So towards intelligence and industrialization, so it is again, you have so many things which is robo-assisted. So data science is very important. Model and data analytics is very important to get the data. How do we use AI ML in manufacturing to the fullest extent? Improve data, define your goal, apply AL, access, and build a data-driven culture. So ML in manufacturing, it can be used in supply chain management and customer. So these are the things for manufacturing, supply chain, and customer support. So with that, I am very thankful to you all for patiently listening to me. A baby learns to crawl, walk, and then run. We are in crawling stage as of now with the data, whatever is on. When it comes to applying machine learning, we are still in crawling stage. We have to walk and then we have to run to make use of this concept of smart factories in the near future. With that, thank you very much for your time. Thank you very much to the organizers. I am open for questions if there are any.
Thank you so much, sir. Participants, if you are having any question, you can put your questions here. I thank you so much, sir, because of this very beautiful presentation. Person who even knows the machine learning less, also he will be interested to know this subject after going through this presentation. One request from our end is, if possible, sir, kindly share the PPT, because as our workshop is in the hybrid mode, so some of the participants may not hear clearly due to network issues who are online. So it would be a great help if you kindly send the PPT to us in your suitable time.
Okay. Done.
Again, participants, if you are having any question, you can put it here. Otherwise, so okay. Sir, we are having one question, sir. How machine learning can give advantage to renewable energy sector, sir?
See, now you have so much of data. Wind energy is developing data. So the wind energy data depends on temperature, humidity, direction, time. So you have so much of data. So now all these data you collect it and keep it, and then you try to predict it, forecast it. Then accordingly you try to change the direction of the windmill. So that is all getting done today. So there is a huge necessity for this thing, necessity for optimizing forecasting using machine learning is done in the electrical industry.
Yes, sir. We have one more question. It's come.
Machine learning, why using machine learning in material development?
Sir, why using machine learning in material development? So, means how it can be used. That's your question, no, sir. Hello, sir.
Yeah.
In material development, he wants to know that how machine learning can be used for material development.
Material development?
Or are you trying
Material
to
development for what? Manufacturing? Or
manufacturing purpose? Yeah, are you trying to manufacture advanced materials with is there scope?
yeah, see, you have strength. So you suppose, let's take a composite. Composite is made of material A, B, C, D, E. So now what proportion of A you should take? When do you mix? How do you mix? What is the output you want? Today we want very high strength, very high toughness. These are all properties which are mixed. So now how do you disperse? How do you disperse? What dispersion will give you? All those things these are all inputs. So based on the input, you will try to generate a sound quality output. So that is what is talked about.
Sir, we have one more question, sir, from Jitendra Rawat. There are lots of models in machine learning. So how do you select the optimal model for manufacturing defects?
See that there is nothing called a straightforward algorithm. So you have to use, at least you have to learn some 10 algorithms, and from that only you will try to use. So you cannot use it. So you need a lot of algorithms to be made, and then you start using it.
Okay, sir. Okay, thank you so much, sir. Thank you once again for giving us the time, and it was really we are really happy to hear you, and we are delighted to hear you. Sir.
No, I don't know whether I did. Sorry, I just pushed the conveners to be very
No, sir, not at all.
sorry.
Sir.
Yeah, so I thank all the audience, and it is very good, sir. I always have a love for Northeast. I will look forward for a chance to come to Northeast and then meet you once again. I have already shared my presentation with you, so please. I've already done it. In your WhatsApp, it is there. Huh?
Yes, sir. Yes, sir.
Okay, thank you so much. Wish you all good luck, all the best.
Thank you, sir. Thank you.